Hello KG5 and Year 11, this is Mr. K back for another chemistry video. I hope you've all had a fantastic time on challenge week. You've really pushed the boundaries of what you either know or you've really challenged yourself. And I hope you've also challenged yourself in the latest chemistry test. But don't worry too much if you didn't get the score you were hoping for. That's the whole point of this video, is that you can learn from your mistakes, and that's far more important than the actual score you'll get. I know you don't really think so at this point in time, but honestly it really is. So just to start off, question 1: which of these dot and cross diagrams correctly represents a molecule of ethene? Now it's important to remember here that it has given you a little description of what the crosses and dots mean. So a cross is for carbon and a dot is for hydrogen. Now this is ethene as well, so you should remember ethene means that it's got a double bond carbon to carbon. Now each bond represents 2 crosses, so if you have 2 bonds, that will be a total of 4 electrons between the 2 carbons. So we're looking for a diagram which has this. So the only one present would be C or D. Okay, so we can rule out B and we can rule out A, because both A has a double bond, but for some reason it's got the hydrogen electrons in the middle, which obviously aren't part of the double bond, and B only has a single bond, so it can't be that one. If we look at C, it kind of looks okay, but then the 2 electrons for the carbon to hydrogen bond are both given by hydrogen in this diagram. Now this obviously isn't the case, or you should know that this isn't the case, and in fact again it is still a shared pair of electrons, 1 electron coming from carbon and 1 electron coming from hydrogen, so in which case it should be diagram D. So D would be the correct answer for that one. Question 2: in industry, ethane is reacted with steam to form ethanol. In this reaction, 2,800 tons produce 230 tons of ethanol. Which of the statements is true? So the atom economy, in this case, you can actually see both reactants go to form all the products, so there's no wastage here. So this question mark, that doesn't exist. But if you were to put the numbers in, you would have 28 plus 18, so these are the MRs of these compounds, that's 28 and water's 18, divided by the MR of ethanol, which is 46, and times 100, and this would equal 100%. So the top one is true. And then to answer whether the percentage yield is 5%, let's think about moles. So 1 mole of C2H4 will go to form 1 mole of C2H5O5. So this is the ethanol, and 1 mole of ethane. So calculating the moles, well, we've got 2,800 tons, so 280 divided by 28 equals 100. And then we've got 230 tons of ethanol. So that's of ethane, and then we're going to have 230 divided by the MR, which is 46, equals 5 of ethanol. Now if we then compare that 5 to 100, so 5 moles to 100 moles, and times it by 100, this will obviously equal 5%. So statement 2 is also true, so therefore the answer is C. Just to go into it in a little bit more detail, don't be confused by the word tons. Okay, given both are given in tons, so you essentially can replace grams with tons. Okay, you could convert tons to grams, but you're just kind of wasting a few calculations there. As both are given in tons, just stick with tons. Following on from that, technically you're not actually forming 100, that isn't actually 100 moles of ethane, and it isn't actually 5 moles of ethanol, since I've used tons and not grams. Question 3, ethene and propene are alkenes. Which formula shows the structure of polypropene? So it's prop, so this means 3 carbons. Okay, so we can straight away rule out that one because it's got 2. This one's got 4 carbons. This one has 4 carbons, leaving the only plausible option as B. Okay, we can see a diagram here that you would have seen in a lab, porous pot or ceramic pot, as we often call it in the lab. And we've got a hydrocarbon on mineral wool, and essentially underneath here there would be a lovely Bunsen burner, providing heat. Anyway, naming the process, this should be cracking, so we can rule out those 2. And then conditions used, as I've just drawn there, high temperature. So the answer should be A. This question is a classic example of actually remembering to revise your lab work. Don't just revise the theory, because you would have done that practical, and if you remembered it, it should have been reasonably easy. Question 5, the reaction to make ammonia from nitrogen and hydrogen is exothermic. Okay, so jumping straight in. During the reaction, the energy required to break the bonds is greater than energy released when the new bonds are formed. Now, given that it's exothermic, this means the bonds forming, or the bonds making, is going to be greater, given that that is the exothermic process. Okay, but statement 1 says the opposite. It says required to break is greater. Now, breaking is an endothermic process, so if that is greater, then it would be endothermic. So statement 1 is incorrect. When atoms form bonds, the process is endothermic. Again, going back to this, bonds forming is exothermic. When bonds break, this is endothermic. Okay, so statement 2 is also incorrect, because forming bonds is not endo, it is exo. So neither 1 nor 2 are correct, so the answer should be D. Okay, along the lines of organics, these fuels are all from the same raw material, so we're looking for crude oil. Don't just put oil, crude oil. Name the process used to separate these fuels from raw material. We are looking for fractional distillation. Which 2 of these fuels are used more often in car engines? This would be petrol or diesel. Bit of a weird question, given that you're not old enough to drive yet, but the moment that you're allowed to drive, you'd know that straight away. So we've got a table here with various different hydrocarbons and boiling points, but going straight to the question, name 2 elements in here present in these 2 elements present in these hydrocarbons. We are looking for carbon and hydrogen. What must she add to the glucose solution to start this process? She's trying to start fermentation, so she needs to add yeast. And then a balanced chemical equation, we're looking for C6H12O6. This is our glucose, and it's going to form 2C2H5OH. This is the ethanol plus CO2, and we're going to have 2 CO2s as well. We could also, for the ethanol, accept C2H6O. Then next question. Sorry, I forgot to add here where the marks are worth. So 1 mark is for getting the products correct, so just ethanol and CO2, and then 1 mark is for the correct balancing. So always remember, if you can't balance but you think you know the compounds formed, write the compounds that are formed and then balance later. Okay, so here we have a mole calculation. So just drawing a triangle out, we've got mass, MR, and moles, and the relative formula mass of ethanol equals 46. Okay, you do this by adding all of these atoms together. So we've got 2 times 12 plus 6 plus 16. Okay, and then the mole calculation itself. So the mass is 1000 grams and the MR is 46. So this equals 21.7 moles. And 2 marks there. So 1 mark for the RFM of ethanol, showing that you calculated it, and then 2nd mark is for the moles. Next question, calculate the volume of 1000 grams of ethanol vapor I'll start again. Calculate the volume that 1000 gram ethanol vapor would occupy under the conditions of the reaction. And then it gives you a nice lovely hint here. So 1 mole occupies 50 decimeters cubed. You've already got the moles from the answer before. So this is going to be 21.7 times 50, and this equals 1085 decimeters. You would also get error carried forward marks here if your question 1 was incorrect. And then what volume of ethene would be measured under these conditions? Well, let's go back and look at the mole ratio. So we can see here there is an invisible 1 by the ethanol, and there is an invisible 1 next to the ethene. So they're the same mole ratio, so it is 1 to 1, and therefore the answer is the same as what you previously wrote, which is 1085. What is a polymer? So a polymer is a large molecule of repeating small monomers forming a chain. And the mark scheme here is looking for the idea of a chain or large molecules, so that's your mark 1, and repeating small monomers would be mark 2, or small molecules. Why is it described as an addition polymer? There is only, and that word is important there, 1 monomer. You could also say made from alkenes. So it's an addition and not substitution, because they combine and there isn't a second product. You just form the polymer. Okay, so just to explain that again, you have many monomers forming a single polymer, and there's no side product coming off that, so they add on to each other rather than substituting each other. Draw the structure of a propene molecule. So prop and ene, prop meaning 3 carbons and the ene meaning a double bond. Each carbon then also only has 4 bonds coming off it. So it should look like this. If there isn't a double bond present, this is worth mark 1. The rest of the molecule being correct is worth mark 2. If there isn't a double bond, it scores 0. And if there's more than one double bond, it scores 0. You could also, I'll say that again. You could also draw this with the double bond in the center, looking like this. Okay, that's another way of drawing it, and that would also be correct. In terms of covalent bonds, explain how molecules of propene combine to form the polymer. So, carbon to carbon double bond breaks, and a new covalent bond links to make chain. Two marks there for those two sentences. So polypropene is a thermoplastic. If you heat it, it can change shape, and this is essentially, it is melting. So molecules can slide or separate, and that is due to weak links or intermolecular forces being broken. Okay, so any two of those three statements. Give one reason why recycling is important. You should all know this by now, but conserve resources. Option. So reduce CO2 from burning waste, like the incinerator in Hong Kong, can be made into new polymers, so you can reuse it, and this is because it doesn't degrade. So any of those reasons for the mark. Describe a test for unsaturated hydrocarbons. So we are looking for add bromine, and you could say water, but bromine's the important word there, and then you need a color change. So orange to colorless. Remember, not clear, but it should be colorless. You could also say decolorized. That would have been fine. So bromine for 1 mark and the color change for the second. Write a balanced chemical equation. What we are looking for here is C10H22. This is going to form 2C3H6 plus C4H10. So the way you work this question out, a bit of a tricky one here. It says 2 molecules of propene. So propene equals 3 carbons. Equals 3 carbons. And if you times this by 2, that would be 6 carbons. So then you needed one other molecule to add, because it just says one more molecule, which is going to make up the other 4 carbons. And so that's C4, and then the remaining hydrogen. So we've got 2 times 6 hydrogen here, so that's 12. So I need another 10 to make it up to 22. Okay, so this compound, so this molecule is being broken down. So you can't have any extra carbon than C10, and we can't have any extra hydrogen than 22. So you just had to add all that up. and so I'll say that again, 1 mark for each of the products, or it might be 1 mark for the products and 1 mark for the balancing. What feature of the propene molecule enables it to form the polymer? This is the double bond, making the alkanes, so the alkenes much more reactive than the alkanes. Draw the structure of the repeating unit of polypropene. This often confuses students, and what I would suggest is you imagine that you've drawn the molecule with a double bond in the middle, and then let's draw our carbon going down. Okay, and you've added all the hydrogens on. Oop, I've added an extra one there. Now imagine this double bond breaks and bond forms out that way, bond forms out that way. We can then add the brackets and add the N. So draw this CH3 off as a side chain. Okay, to make the diagram much nicer, you could even draw it as CH3 if you wanted to. Why is a more expensive polypropene used to make fizzy bottles? It is stronger or more rigid. When a fuel burns, the product contains less energy than the reactants. So if fuel is burning, and if the products have less energy, it means that energy has gone somewhere and it's been lost to the environment. So it's an exothermic reaction. Next question. So why do the products contain less energy? Breaking bonds needs energy. Forming bonds releases energy. So more energy is released than is used, i.e. more energy is formed from bonds forming, and well, not more energy is released from bonds forming rather than energy being used up to break bonds. So therefore overall energy given out as heat, and you could have any 3 of those marking points. And finally, last question, what is an endothermic reaction? It takes in heat energy, or thermal energy, if you want to be more specific. Thank you. I hope you've enjoyed the video. Please leave comments for any suggestions, and if you want anything else further explained, I will be quite happy to, or just go and see your teacher because they're probably a lot closer to you. Thank you.